Hey everyone, welcome to the first video for section 3.5 in the textbook. So now we've taken care of 3.7, doing the physical applications for homogeneous equations, now we're going to go back and look at how we solve non-homogeneous equations and then go into the applications of those. So to me this order makes more sense than the book's order, but so be it. So we're going to do it this way. So this video is going to be a sort of general introduction to non-homogeneous equations and sort of what they are, what the solutions should look like, and then we'll talk about sort of methods to solve them in future videos. Let's go ahead and jump on into it. So we're talking about here non-homogeneous equations. So going back to the notation we used before for this operator L sort of stuff, this seems to be looking at something of the form L of y equals g of t. So now we don't have a zero on the right-hand side anymore. We have some function g that we want to figure out. Now we know from section 3.2 from our theory section that we can solve L of y equals 0. So we know that if we had L of y equals 0, then y is of the form y equals c1y1 plus c2y2, where y1 and y2 are a fundamental set of solutions. Right, we know that, we've done that before. Turns out that's going to come up in a little bit for how we know something about our current situation. So I just want to get that out of the way now. And now we're going to say, what if we have two solutions to this non-homogeneous equation? So assume that y1, these are going to be capital letters, and y2 satisfy L of y1 equals g of t, and L of y2 equals g of t. Well, then what is L of y1 minus y2? We did all of this work when we talked about the principle of superposition back in section 3.2. Basically what it said is that I could do addition, subtraction. I could separate those outside of the L. So I know that this is equal to L of y1 minus L of y2. If you want to go back to that video and look at it again, you can. But L of y1 is g, L of y2 is g. So this is 0. So what I have is I have this function here, and I know that L of it equals 0. But we just talked about 2 seconds ago what that means. If that equals 0, then I know y1 minus y2 equals c1y1 plus c2y2 for some constants c1 and c2. So I know exactly what this difference here looks like, which means any solution to L of y equals g is equivalent to some particular solution, some capital Y, plus the homogeneous case, because I can move this around and say that I know y1 equals c1y1 plus c2y2 plus y2, and this holds for any two solutions, y1 and y2, to L of y equals g of t. Right, so for any two solutions, I know this is the case. What this means for me is if I can find any one solution to L of y equals g, then I know how to get all other solutions to L of y equals g, and that's just by adding a solution to the homogeneous problem. So if I can find any y solving L of y equals g, then all other solutions y hat to L of y hat equals g are of the form y hat equals y plus c1y1 plus c2y2 for some constants c1 and c2. And this is exactly the statement of theorem 3.5.2 in the book. They use phi for this y hat, but the idea is the same. This thing gives me a general solution to my non-homogeneous problem, because any solution of the non-homogeneous problem must be of this form. So if I can find a y, I then just have to pick the right constant c1 and c2 to get the certain solution I want. So this gives me a general solution to the non-homogeneous problem. So from this, we get a good suggestion of a method to solve non-homogeneous problems. Step 1 is solve the homogeneous problem. This is what we did in sections 3.1 up through 3.4 was figure out ways to solve the homogeneous problem, especially in the constant coefficient case. Step 2 is find any y solving the non-homogeneous problem. In future videos, we'll get into methods on how to do this. And then 3 is combine them as y plus c1 y1 plus c2 y2. And then 4, find c1 and c2 from initial conditions. And that's the general process for solving these types of problems. The hard step, the one we haven't done yet, is this step 2. And that's what the next 2 sections handle. The next 2 sections handle different ways of trying to solve for this step 2, finding this any y that solves the non-homogeneous problem. The way in this section is a little more intuitive and a little more sort of obvious and sort of a way that makes sense. You can think about it. The other way is a more direct mathematical way that always works, but can sometimes be impossible to actually solve out. So in the next couple of videos, we'll be going over what this method is. It's called the method of undetermined coefficients for finding this y. And we'll go through how this all works, how it all comes together, and figure out how to solve these problems. All right, so that's it for this video. That's the point here. In the next video, we'll actually go into what this method is and how we solve equations using it. Thanks a lot for watching, and I'll see you in the next one.